Welcome to RailsConf. I am Brian Sam-Bodden, Rails, Ruby, Java consultant. I run a small company in Scottsdale, Arizona. And I'm here to talk about RSpec and Capybara. And testing is one of those subjects that in most frameworks and languages, we kind of took for granted. It's like, oh, it's the stuff that we do at the end of the show. So the Rails community actually took that and flipped it on its head. I believe probably one of the earliest versions of Rails already had a built-in testing framework that showed that you could automate web testing. So in this talk, I'm going to talk about practical behavior-driven development. We're going to be talking about test-driven development, TDD. And I'm going to try not to be dogmatic about it. And one of the things that kind of drove me away from testing early on was that people were too religious about it. It felt really weird, like I was joining a cult. But once I actually got into the practice of it, I started seeing the value. So I'm going to show you some of the practices that I use in my daily work and how TDD and RSpec and Capybara can help you build better applications. I want to be able to make you comfortable with the tools, RSpec and Capybara in this specific talk, and the practices. So for today, you're going to need Git. I do have a backup zip file, so if you don't have Git, we can probably try that. I will have to break to show you the link for that. It's actually the same link as the PDF, but with zip at the end. So a very nice, lengthy URL for you to type. RVM, I do have an .rvmrc file in the application that you're going to be playing with that will just create a gem set for you to work with. So let me see a show of hands. How many of you are familiar with Git? Oh, cake. This is awesome. How about RVM? All right. Ruby? All right, so if you got all that stuff, we're good to go. We're going to be cooking with fire. And I don't really care about what text editor you use. As long as you have a QWERTY keyboard, we should probably be good to go. So we have 80 minutes of time to cover RSpec and Capybara. I'm going to start with RSpec, BDD and TDD, then we'll jump into Capybara, 40 minutes and 40 minutes. I'm going to mix lecture and code and follow-along coding. So it's not one of those that you can basically listen to the lecture and skip out of town. So hopefully you're ready to actually write some code. Not too much, but enough. I have two images on the slides that indicate whether I want you to follow along with me, which is that green follow along sign. And there's two labs, two very simple labs that we're going to be able to do at the end of each of the 40-minute sessions. All right, so let's talk about testing. Unit, integration, acceptance, behavior-driven development, and test-driven development. It's a lot of acronyms to be thrown out there. In the Agile Manifesto, this is the actual phrase that stood up in my mind when I was actually trying to correlate testing with the quality of our applications. And it's at our highest priority, it's to deliver the most value to the customer. And value doesn't mean documentation, doesn't mean anything other than code. Runnable, testable, reproducible behavior in code, it's what our customers are looking for. And that is the direction that all the practices in the Rails and Ruby community have taken development towards. So let me see, how many of you came from, let's say, a Java background? Okay, get out. Just get in. Just get in. I'm there too. How about C, C++? All right. When I was doing C and C++, I mean, testing was the last thing in our minds. We actually ran through the whole code. Testing was basically visual, or we actually would look at the behavior of the application and hope for the best. And if somebody changed something, as the application got more and more complex, things got more and more complex to verify. So testing, in the waterfall methodology was the thing that we did at the end. Obviously, most projects had a flag in the sand in terms of a calendar date that they wanted to be done by. And we never actually got to slap the testing into that period of time. We ended up basically saying, oh, well, it didn't quite happen. Most languages didn't have a good framework support for testing. And it all started with Smalltalk, but really with Java and JUnit. And from that point on, things really sprout. Testing frameworks appear in every language that we see out there. In the Ruby world, we had test unit from the get-go. I'm going to be showing RSpec, which is now, I would say, an evolution on test unit. It's test unit with the language capabilities to do behavior-driven development. One of the problems with unit testing frameworks is that when we start using them, we learn to unit test. But the unit testing frameworks are used to do every aspect of testing, from integration to acceptance, user testing. Everything is done with the same framework. So our problem is where to start. And we always start at the unit because that's what we learn the framework, that's the essence of the framework. But it's not where you get the most value out of testing. This happened to me a lot in the Java world. We had tons and tons of models or business objects that were very well tested, but the controllers were a disaster because it was pretty hard to basically, even after having a pretty well tested model layer, to test integration between the controllers and the models and the views. Well, let's not even talk about the views. That typically is the Vietnam of web applications. That's where you just throw your feet up in the air and say, forget it. So BDD, behavior-driven development, the idea is to reverse the tendency of us testing the smallest units that stand in isolation and start from the outside in. So there's a lot of BDD testing frameworks that have evolved over the years. And by far, my favorite happens to be RSpec. There are RSpec clones in pretty much every language out there. The same thing as you have Rails clones in pretty much every other language, you also have RSpec clones in there. And one of the things that I mentioned before is that integration testing, it's pretty damn hard. And it's the hardest in the middle layers of the application. For example, between the controllers and the models, and between the view and the controllers. And what we try to do with behavior-driven development is start at the view and complement those tests at the model and leave the stuff in the middle as the Wild West until the application solidifies. Because testing in that area actually becomes pretty expensive because those are very fragile and brittle tests because the application is in flux all the time. And when we started, we had this mantra in our minds that we wanted to do 100% code coverage. And we paid dearly for that. Every time that we had a 100% code coverage application on January, in February we had a 40% code coverage application with 60% of broken tests that nobody wanted to refactor. So we learned that to start at the edges of the equation. And I'll show you in a second how we do that. So just to, how many of you work with Rails on the daily basis? Or, you want to work with Rails on the daily basis. Okay, that's a pretty big majority of everybody here. Just to refresh your memory, we have a traditional, request handling in Rails. And I'll try not to look at my own screen here because I have it right here. I call that the reverse weatherman. It looks really weird in video too. So we have the view. That's where we want to concentrate our outer layer testing. And as we're testing in there, we're basically going to assume a lot of things about the inner layers of the application until you get to the model. It's okay to actually flesh out the models in there so you basically have the two ends of the equation agreeing with each other. And I put a little diagram together of what I think things should work like. So at the top, you see that I have number one, it's basically write a failing acceptance test. And by that I mean mimic something that the user does. So the user is actually putting some data in some edit field. They're pressing a submit button. They're expecting to see something on the screen. A pop-up comes up. A flash message appears. That's the type of things that we want to test at the outer layer of the application. And I call that acceptance testing because it's between your application and the user. Some of the tests in there would be the things that you want to have as a checklist for the user to say, yes, that works, yes, that behaves as expected. But not every acceptance, not every test at that layer becomes an acceptance criteria-bound test because some of them are a lot of edge cases that the users don't really care about. The ones that they don't care about, we care about. It's because we want to be warm and fuzzy about the application that we wrote. So you notice that inside, between the views and the controllers, in this example I have one view maybe talking to two controllers. At that level, I do TDD, but I do TDD to flesh out the controllers. And The only reason I'm doing TDD at that level is because I don't really know what I'm doing. I want to figure out what the controller should do. And that's why I use TDD in those inner layers. But still, the thing that's dictating the whole process is that outer acceptance testing that I started with. The same thing happens when I get to the models. One controller might be using multiple models, and then at the model level, now I'm fleshing out, designing the API of the models by using TDD. So if you look on the right-hand side of the diagram, notice that I have this arrow going down to the acceptance testing and returning. That is the big outer loop. Then inside of that, there's going to be a lot of mini loops, testing, integration testing between the controllers and the models. And then at the model level, I have tiny little TDD loops to actually flesh out the models. So let's talk a little bit about BDD and why do we call it behavior-driven development. When I started doing TDD and unit testing, I couldn't see really the difference between the two. Sometimes I thought, well, if I'm using test unit, is it unit testing? If I use RSpec, it's by definition integration testing or an outer layer testing. And that's not the case. It's really what's important to the user. And what's important to the user is what they can perceive. And that's where eventually we'll see how Capybara comes into the equation. So behavior-driven development. It takes TDD and focuses TDD to get maximum value for stakeholders. And that's a very blown, enterprisey statement that I think I pasted from somewhere. But what it means is that you really want to test the users kicking the tires of your application. And sometimes you don't even know what those tests are going to be. One of the approaches that we have is that our designers will actually come up with a UI that the users believe it's what they need. And then we see them using it, and we realize this is going to be impossible. And that UI evolves just between the designers and the users as a conversation. There's not even tests to back anything up. But once they get to the point that they have a mini workflow in their mind that actually makes sense, that's where we jump in with our Capybara acceptance-driven testing. So BDD also implies that you're going from the outside in, and also implies that you're refining the language. You're refining the language to be something that the users can understand. In BDD, we use specifications. In RSpec, the spec part of RSpec, it's specification. Show of hands again. How many of you are using RSpec to test your software? Okay, so we can probably move faster than this. Now, one of the things that sometimes it feels weird when you're using a framework like RSpec, when you're fleshing out a model, it's that you're wondering, wait, this is way too far away from the user. But again, it's just the framework allows us to write the same unit test that we had before with something like test unit in a cleaner fashion. All right, so what to test? Only the things that matter to the user. Typically would be the reflection of a user story, or if you're using use cases, it would be probably a scenario of a use case. Where to start? From the outermost layer. In the case of web applications, it would be a web page. Most likely a form. What to ignore? Everything else. And again, I emphasize to ignore the stuff in the middle, because that's the stuff that's in heavy flux that you need to ignore until it solidifies the whole architecture and design of the app. So typically we have user stories that look like this. We have, as a role, I want to accomplish some goal so I can benefit in a certain way. And with RSpec, in most of the BDD frameworks, it translates pretty much directly to given some state, some role in some state, when an action happens or when a specific event occurs, I want to benefit in a certain way from the application. Like the application might be returning a new page with some set of data that I'm expecting. So now we're about to kick the tires with the tutorial. So we're going to do a little TDD tutorial with RSpec. It's going to be focused at the unit level. So I don't want you to be misled by that, because I just want you to get the mechanics of RSpec. It looks like most of you have used RSpec before, so we might be able to move really fast through this. Just to give you a couple backgrounders on RSpec, it is by far the most popular BDD framework for the Ruby platform. It's been around for a while now. I mean, it's going into past the toddler stage. And it provides a DSL that allows you to test in the language of BDD. Another nice thing about RSpec is that a lot of different frameworks integrate with RSpec by providing matchers, that allow you to express something in the language of BDD. So here's a very quick example of what an RSpec specification looks like. And in here, at the contrast is a little bad in there, but the whole thing is called the example group. So that describe block is an example group. Inside, I have specific examples or specifications. In this one I'm describing a score in bowling. It returns 0 for a gutter game. Notice that down below, I have an expectation. So we've set up some state, we produce some event or action, and then we see what the specification it's looking to validate. So in this case, I'm expecting that the bowling score to be equal to 0. Now, for those of you that have been using RSpec for a while, the spec syntax, it's fairly new. I mean, probably the last year and a half or so. You are probably used to seeing should do something or other. Spec seems to be the new kid on the block, and most tutorials, most books are moving towards spec because it kind of blocks your expectations in a nice block of code. And that equals 0, it's the matcher. And once we jump into Capybara, you'll find out that there's a lot of matchers that allow you to basically deal with things that happen on a web page. Now, RSpec has a bunch of different matchers to do pretty much every type of comparison you can think of. From Booleans to checking if something actually exists or not, expectations of raised errors or specific errors being thrown, and it also creates a DSL over specific methods that you have. So if you have a method called exists, question mark, you can say expects to exist. And there's also a lot of nice collection methods. There's also regular expression matchers. And those are pretty useful, too, when you're dealing with a web application. So again, let's jump into TDD with RSpec. TDD, not really about testing. Every time that I used to hear that phrase, I'm like, what do you mean? It's a testing framework. I'm writing tests. The key point in here is that when you're not quite sure what that class should do, TDD might help you clarify your thinking about it. So TDD isn't really about testing, it's about design. Not all of your tests will be about design. Some of them will be about corroborating some design that you already had preconceived in your mind. So it's a combination of both. Obviously, TDD leads to cleaner code and separation of concerns. Every time that I write something without following TDD, I end up with way more code than I needed. And one of the tendencies that programmers have is that we like to abstract and simplify. So somebody tells us, hey, you need a method in this controller to do this. They walk away from you for 2 weeks. They come back, and you wrote a framework or a library. Not what you were asked to do. I tend to do that all the time. It's like, oh, yeah, here's a gem that I created because you asked me to validate an email in a controller. So TDD also curbs that tendency that we have to basically write too much, over-design, over-engineer things. Now, one of the things that I really like about TDD, it's this kind of zone that you get into once you have TDD down. And I've been doing TDD for about 10 years now, and I'm by no means an expert. Some days, I'm like, I don't think I can TDD anything today. I'm just going to hack it on the IRB or on the Rails console, and then I write a test about it. But that's actually perfectly fine. For example, the IRB or the Rails console, it's a great learning environment for you to kind of get your whereabouts of how to put that test together to start the TDD cycle. So sometimes I do that. I'll be playing with some API that I don't know anything about on the Rails console for a couple hours before I write the first test. The good thing is, that I like about the Rails console and IRB is that I don't commit that code to anywhere. When I do it in an RB file, I have this tendency, I'm just going to check it in because I don't want to lose it. And now you have code that it's legacy code the moment you push that into your Git repository. So it also gives you this lightweight rigor. So you're basically, it's making development really goal-oriented. And when you have, we're a consultancy, so when you have customers being goal-oriented, it's actually pretty good for the customers. In TDD, we have this loop that we call red-green refactor. And I have a little illustration of red-green refactoring here. So you start with failure. This is probably the only activity in life where starting with failure is a good thing. Like sometimes I'm sitting there trying to come up with the test, and when I finally have the test and I run it and it breaks, I'm like, yes, broken test. And it's, you know, if you were to do that 20 years ago, people would be like, what is wrong with him? So then green, how to arrive to green, and now again, that it takes a lot of practice to arrive to green without doing too much. But also not being dogmatic and doing way too little. Sometimes we do very silly things and we do like a 8-loop TDD cycle to come up with A equals B or something like that, a simple assignment. So as you get better with TDD, you have to balance those forces. And then once you have the minimal possible thing that would work, that would satisfy that test, then refactoring means making it better. When you refactor, sometimes new things sprout out of the whole thing. Those things that sprout, don't write code for them, write tests for them. So you restart your TDD cycle with the new ideas that came out from understanding what you just wrote. All right, so for this follow along, what I want you to do first is to create a directory. You can call it whatever you want it to be called. I called mine RSpec follow along. And then I'm going to CD to that directory and create an RVM RC file. If you're using any other Ruby version manager or gemset manager, do the equivalent that you would do with that one. I'm also creating a gem file. And that gem file is going to have the very simple contents that I have in here, basically. I have one simple group called test, and inside of that, I'm declaring the gem RSpec. Once you have that in place, we can actually run the bundle command. You might need to install gem install bundler if you don't have bundler already in your system. And once you have bundler installed, we can bundle the whole thing, and we should have now a directory ready to be played with. Now, if you get stuck and you see somebody next to you that looks like they got it working, just peek over their shoulder. Since we don't have much in terms of assistance today, so I'm going to try not to step away from the podium. All right, let me see. Show of hands. Who's got the directory going? Okay, we're getting pretty damn close. Awesome. Okay, so if you're using RVM, you're going to have to CD out of the directory and CD back in so it recognizes the .rvm rc file. And then we can run bundle. If you haven't installed bundler, you probably have to install bundler too. You can see some of the dependencies that RSpec will pull in. And I believe that my RSpec version, it's 1 point behind, but what I have in the running demo, it's actual 2.13.0, which I believe it's the latest one. 2.13.1? Okay, so let's start our red-green refactor loop with the simplest possible failure. We're going to build this mini shopping cart, pure Ruby right now. And I wanted you to start with the CarSpec, which is going to be in the CarSpec RB, and it's going to have just a describe word, a describe block that specifies a class that we don't have yet, cart. And it's going to be an empty body block of code. Now, obviously, there's a lot of places we could take a shopping cart, but we're going to keep it pretty simple so we get the mechanics of RSpec so we can jump freely into Capybara without worrying about the RSpec mechanics. So with the CarSpec in place, we can actually run the test. Typically, you will be typing RSpec. You can probably just type RSpec without the spec command in there, and you should get that we have no card class. So in our case, this is possibly the simplest failure that we can get. Now, in practice, I don't always use the simplest failure that I could get. Sometimes I fast forward a couple TDD cycles in my mind. The trick here is not to fast forward too far, where you start basically losing track of some of the dependencies that might be in there. So early on, it's okay to fast forward. Later on, you will pay for it. Now notice that I have a hint in there that says that if you have a failure when you don't have any test, typically means that you're basically missing a test to account for that failure. Because a failure, it's a failure, and you should be able to test that a failure exists. So in the next section, now I'm creating my empty card class, which goes with my describe card block that happens to be in my CarSpec RB. And notice that I'm doing a required relative. Since we're not in Rails, things that don't get required automatically, so I'm doing a required relative to bring the card class that's supposed to be in my lib directory. Now, if you go back, I probably missed this, but you were supposed to put the CarSpec on the spec directory. So if you didn't do that, go ahead and create that directory and move it there. I totally missed that in my slides. But now that we have an empty card and we have a CarSpec that's empty, we can actually run RSpec again and basically get a zero failure RSpec run. But notice that we also have no examples. But before, we had a failure. So one of the things that I like to do with some systems is to make sure that that failure is explicit in my system now. And that's what I'm doing further down the line. So now let's tackle our first realistic test in here. And the spec is going to verify what happens when we get a brand new card. And notice that I have now an extra block called context that says context, some string, and another block of code. Now, RSpec allows you to daisy chain all these initial states of what you're testing in a very clean fashion. So in here, I'm saying a new card, contains no items. Inside of the it block, I have an expectation that the instance variable card should be empty. Now, this is making a lot of assumptions. Those assumptions, it's where the design part of the equation comes in. I made in my mind the design decisions that the card is going to be something that responds to the empty method, so empty question mark. It could be a hash, it could be an array, but we haven't gotten there yet. But at least we made one decision, and this is an API design decision. I also made the decision that I have an instance variable named card. So you start coming up with these mini decisions that eventually coalesce into a real design. So I'll give you guys a couple seconds to flesh out that spec. So I guess, again, I'm expecting my cart to be empty. If I run RSpec now, you will see that I have one example and one failure. The failure is that we don't have a method empty on the cart instance variable because it doesn't exist. So again, we're inching forward towards having something real in there. But one of the things I really like about TDD is that this microprocess, while running tests, allow you to think in a much more organized fashion about what you're building. And once we go out to the outer layer testing, it will make even more sense. So we arrived at a real red state. We have failure, and that's a good thing. Now we can start writing the minimal amount of code to pass that test. So again, with BDD, one of the main ideas is that you want to get the words right, because those words reflect your intent in the code. And if you get them wrong, eventually somebody's going to refactor your code to do the wrong thing. So get the words right from the get-go. You probably noticed that when we ran the test, the output of RSpec said, card, a new card contains no items. That doesn't read really well. That's the beauty of RSpec. You have free-flowing strings in there to basically make sure that the output of the test reads like something that makes sense. So I'm refactoring the test a little bit to basically say, and I'm adding a little bit of programmer lingo in here because I want to know which entities I'm dealing with. I'm saying describe an instance of passing the class card. By actually passing the class object in there, RSpec knows that you're dealing with that card class, and it's expecting that card class to exist. The next context block says, when new, do, now read the green parts only. An instance of card, when new, it contains no items, or contains no items. And that's what we're looking for. We're looking for this fluidity that is going to come out with a statement of truth about our system. And it's going to reflect the design that we just implemented. So a little bit of refactoring to get the language right. And again, we run the spec, and now we see the language appearing correctly on our output. Now, the next thing we want to do, it's implement the very simplest possible thing that we can do to pass this. But first, I want to address what I was talking about a few slides ago. I kind of jumped the gun in there. It's that we had two failures. We had an explicit failure, the assumption that we had an empty method available, and an implicit failure, the fact that the instance variable card was not there to begin with. And this is probably a good point for discussion. One of the things that we can do, let's address the fact that the text fixture didn't exist. So basically, our card instance variable was not around. So I'm going to create a very simple one by saying @card equals card new. And where should I put that? So when I started using RSpec, basically, you will just put it right on top of that expect line, and you would have an object to test on that expectation. The idea of having the describe blocks is to gather specific tests against one state of a class that you're under test. So in our case, we want to test a brand new card. And that's what we want in here. It's to have a before block that tests everything, that sets up everything. So now notice in here that my test, it's an instance of card should be properly initialized. So now that implicit failure, I made it explicit by writing a test about it. And you will see things like this sometimes with, when you're testing against, let's say, an integration test that talks to some mock web service. And you at least want to know that there's a connection between your test and the mock web service. Because in the real scenario, you want to test that you have a connection between your app and some external web service. So again, sometimes these explicit failures where you see RSpec breaking means that you probably want to write a test to cover it. Now, we're still missing functionality. We have a card created, but the card still doesn't respond to the empty method. So the first step is to initialize a card instance on a before block. So you can do things that happen before the whole test class executes or before the specific methods in that describe block execute. So in this case, I'm doing a before each. And the before each means that it's going to run that line that says @card equals card new before every single test in there. So we're effectively resetting the @card variable every single time. How's everybody doing? Going too fast, too slow? Slow down a little bit? Okay. So again, let me recap. In each one of my describe blocks, I describe a scenario. The scenario typically it's driven by some initial state of what I'm testing. In the case of the card, I'm testing a new card. So in my before block, I want to create a brand new card. If I had a scenario that described a card with 2 items on the shopping cart, then in my before block, for all those tests, I would have created a card and added 2 items to the cart. Okay, so now we can really focus on the failure that's going to drive the development of the app. And I'm seeing that an instance of cart, when new, contains no items, and it's failing because the empty method doesn't exist. Now, the purist in TDD will tell you, well, put a def empty question mark and return nil. And that is the simplest thing you can do to get past that failure. I don't like doing that. I think this is a point where you can fast forward a couple TDD cycles and say, well, I want to back my cart with something that supports the storage of the things I'm going to put in there. But just to cover the puristic approach, in here I'm adding an empty method to my cart that returns nil. So now I run my test, and notice it's failing because the empty method is returning nil while it's expecting to return true. So if you're going to muck it or stub it, at least make sure that the stub returns the wrong thing to break the test. Because otherwise, if you're dealing with a lot of classes and it's a complex system and it's further down the road, you might forget about it. And now you have a passing test for some code that it's not what it should be. Okay, so let's flesh out that empty method on the cart. And now, we can comply with the actual specification that we set out to pass by really adding something behind the scenes. So what I'm doing is I'm going to add a constructor or an initialize method to my cart class where I'm creating this instance variable called items. In items, it's going to be an empty hash. I'm also going to refactor that empty method by piping to the empty method of the hash. Okay? It's a pretty clunky implementation, but that's the purpose of TDD. We're going to do the simplest possible thing that came to your mind at that point in time to get things going, and then we'll make them better. So once you have your cart fleshed out like this, so we have an initialized method and an empty method passing to an items instance variable that happens to be a hash, we can run RSpec again and now get two tests that should be passing. Two specifications that are passing. So we reached that holy grail of TDD, the green state. We don't have much to show for, but we're actually building software in a delicate, careful fashion. So once you get to the green state, now it's time to refactor. And in your minds, there's probably about 1 million ideas right now of how you could make this better. Now, early on, refactorings are going to be fairly simple. They're going to be minute things. As you move forward and you start getting from unit testing to integration testing, and you start also from the outside in doing acceptance testing, the correlations between the different things being tested becomes higher and higher and higher, and refactoring becomes a science. At that point, that's when refactoring really, that's where you build your chops refactoring code. So to refactor this simple cart class that we have, the first thing I'm going to do is that I didn't really like that passing of methods to the inner instance variable. So I'm going to use one of the things that actually comes in built in with Ruby, which is the ability to forward something to an inner instance of some object that you own as an object. In this case, and that's called the Ruby forwardable module. So I'm going to extend my class with the forwardable module. I'm going to define a delegator that's saying the empty method, when invoked on the cart class, I'm going to pass it to the items instance. And now I got rid of that. I'm actually using a declarative way to pass the implementation of my inner items instance variable to the outer class. Whether that's a good idea or not, that's debatable too. Now we're sort of exposing implementation specifics. At least the person using the class knows that this is an enumerable or is something that supports enumerable. But notice the class is now simpler. It's cleaner, and we're not basically calling a same name method from another from the outside. So with that refactoring in place, I can run RSpec again and now see that I have a passing suite of specifications. I'll give you guys a couple seconds to catch up. Say that again? Can you paint the screen? We can't read the blue font. Yeah. Oh, I apologize. You just highlight the box. Sometimes it helps. I can't get my cursor. Anybody remembers is it option or control? Control option function 8? Nope. Control option. Mine doesn't want to go there somehow. Hold on, let me bring that code actually in. Look at that, and gigantic too. So again, if we go back and forth, you can see that we have. And you're going to see this ratio between your specifications in your actual code. Sometimes it seems that you have more testing code than you have production code. And that's a good thing. That code is not for the stakeholders, for your customers. That code is for you to feel better about what you just built. And to be able to come back 2 weeks, 6 months, a couple of years down the line and understand what's going on. How many times have you actually opened a file of code and just say to yourself, whoever did this deserves to be fired, and then scroll all the way to the top and find your name? I've done that a couple times. So notice, anybody use required relative before? So it's kind of the new kid in the block when it comes to requiring a file, but it allows you to not have to basically find out the root folder of your application, and it just requires something relative to the actual file you're working with. And you only have to do that here because we don't have Rails scaffold around RSpec in the Rails classes to basically do everything for you. All right. Okay, so let me see, show of hands. How many of you got to get everything working and running and it feels all warm and fuzzy? All right, so the code, it's all going to be available. The next example is all on GitHub. This one I still have to zip up or push to GitHub and give you guys a URL to access it. All right. So now obviously tonight you're not going to go out and drink and party in Portland. You're going to go to your hotel and do some coding. So I left you a few exercises for RSpec to basically flesh out that shopping cart. And I better not see you at the bars, okay?
Where is the slide deck?
They're on Dropbox. There's a URL on the front I'll show again. And they're also on the RubyConfTutorials.com website. RailsConfTutorials.com. Here, let me quickly show you guys that link so you guys have it. And I apologize again because it's a very lengthy Dropbox URL. Actually, let me copy it and try to bit.ly it. Is that an actual verb? Somebody paid billions of dollars for this company, and it's taken it like, what, a minute to shorten a URL? Let's see who wins. There is a tiny URL that you can use. So once you get that, then we'll jump into Capybara. Well, I don't know if this will work by putting .zip at the end. Yeah, this one, it's a PDF. The other one, it's that .zip. And that is just the whole project, but it's the one that we're actually going to work with Capybara, not the one you just did. All right, so I'll let you guys grab that, and let me switch now to the Capybara portion of the show. So again, if you have some free time tonight, there's a nice set of RSpec labs in there to complete. It should take you like all of 15 minutes. All right, so let's talk about now behavior. Yes?
Quick question before we go on. Any idea why the first test would pass and the second would still think that card is nil? Because that's what I'm getting.
I'll stop by at the end and we'll take a look at it. Okay, so behavior-driven development with Capybara. So now, I don't want to mislead you with the RSpec example because it is a unit testing example. It's just showing you the mechanics of TDD. To do real BDD, you want to go out to where the user lives, and that's the browser. So proper acceptance tests, they should treat the application as a black box. That means that they should have no knowledge of internals of the application. The one place where I sometimes break that rule is that I might mimic some JavaScript behavior from Capybara directly. But other than that, I try to treat the application as a black box. Which means that they should know as little as possible about the app and how it behaves. So it's all observation-driven, state-driven testing. Now, Jeff, which was here just a second ago, this is where I got that idea that you really want to test at the outer layers and at the model layer and leave the stuff in between untouched until the application matures. Hey, I copy and pasted from your material too, so thanks, buddy. So Capybara, it's a lightweight alternative to Cucumber. How many of you have used Cucumber? Okay. How many of you like Cucumber? I don't like the damn thing. I'm with DHH on that camp, which I think it's an extra layer of abstraction for a mythical unicorn with wings figure that doesn't exist, which is the actual user that cares about looking at your tests. They care about seeing the behavior live, and the acceptance test is for you to verify that once they said, yes, it works, it continues to work over time. Yes?
The one valid reason for having it is for PM or project managers writing tests.
Yes. Yeah, that is scary. That is a very scary thought. Yes. So yeah, I mean, I try, and actually in my team I have some folks that really love Cucumber, that they really like using Gherkin and Cucumber, and that's where they live. I like to have the control, the power of Ruby at my fingertips to be able to express my tests. And the output of running the test, it still looks pretty, and it's either going to be green or red, and that's all the end users really care about. So Capybara automates your browser. Basically, it's a remote control from your application test suite to control browser actions. And the idea is that you want to simulate how the real users would work with the application. Now, if you take this to the obscene extreme, you basically go into a large corporation where they create Selenium scripts for every possibility. I mean, they really just random click things and put random text in boxes. And that's okay. That's okay to shake the application to see if it breaks under bad input and things like that. But it's really not the type of testing that we're looking for to drive the design of the application. The design of the application, it's mostly sunny day scenarios. It's mostly what would happen when the user does what we expect, and how can we assure that the application responded in the way they expected the application to respond. So by default, Capybara is agnostic about how it controls the browser, and it uses a rack test to control the browser. Rack test gets into that HTTP layer in between the browser and your application and mimics requests to your application. So it's sort of a headless browser. So you don't really see anything happening. That is really good because it's fast. So you can run your integration test or your acceptance test in a CI environment, and you don't really need to have a browser available that is actually going to appear on that CI machine, which is probably not a good thing. You can also, what we use, it's a Phantom.js, which it's a real browser, but a headless real browser. And so that will be above that layer that you have with rack test. There's also Selenium support built in and WebKit support. So in the examples we're going to do, we're going to be using the Selenium support, which nowadays under the cover it uses a WebKit driver. So it's sort of like a Matryoshka doll approach to testing drivers. So like I mentioned before, many developers do not want to bother with Cucumber. I'm one of those. I think it's just too much abstraction on top of what I'm trying to do. So I want outside-in testing with the power of Ruby and not some weird DSL that doesn't match the way I work every day. There used to be, well, there's still a project called Stake that integrated RSpec with Capybara. And as of 2 years ago or 3 years ago, the Capybara project said, hey, everybody's using Capybara via Stake. Let's just mix the whole thing into one. So now Capybara uses the same Stake syntax to drive the test. I mentioned Capybara uses the rack test driver by default. So we're going to change that to basically use the Selenium driver. One of the things that rack tests can do, it's mimic JavaScript behaviors or deal with JavaScript at all. Yes?
So what's the advantage in using Selenium versus the built-in rack test?
So rack test, it's going in between where the browser is and where the application is, talking to the HTTP layer directly without having any of the standard browser communications in there. They're all post and get requests, so it's really the same thing. But you're basically grabbing the HTML as it's coming out of the application and not letting it sit in the browser and then grabbing the DOM from the browser, which we all know that there could be differences in there. So it is really fast, and sometimes we start with rack tests or with a headless browser like Phantom.js because they're really fast. When we move to a CI environment, we also do that. It's completely headless. But when I'm developing, I like to see the browser come up, and I like to see things being dropped down and values selected, and things being dragged and dropped. It really helps you visualize, see this fast-forward movie of the application being used. And like I mentioned, there's the Selenium WebDriver and the Capybara WebKit driver. So we'll be using Selenium WebDriver. The nice folks at Thoughtbot put a cheat sheet for Capybara because every time that I'm using Capybara, I have to look up the documentation to find out where things are. So they put a really nice one together. It's a 2-page PDF, the URL's at the bottom, that I use all the time to basically figure out what I need to do. But as you can see, there's methods to do navigation. There's methods to check things on the page. Whether there's content in here, whether this CSS it's available or applied to something. You can basically scope searches. You can say within this div that matches this CSS class selector, then look for a button that looks like this and click it. You can have weights. And one of the things that you're going to find frustrating is that every time that you have a lot of Ajax functionality, you become a master of figuring out when to wait and for how long. And then trying to find the breaking point between waiting too little because in breaking the test but not waiting too long and slowing down the whole test suite. Obviously, you can interact with the DOM at any point in time. You can click things, you can trigger events, you can check whether something is visible. You can fill in forms, check, uncheck, check boxes in radio buttons, and select, click buttons. There's also a very nice feature called Save and Open Page, where you can save the HTML markup at a specific point in time. There's also a little bit of a trickery to actually take a screenshot, too, of the application. So you can really automate your test to, oh, something broke, save the HTML so I can go and manually inspect the HTML. Or everything seems to work fine, but how about the look and feel? So you can take a snapshot of the screen, and maybe somebody can manually look at that picture and be like, well, on IE7, whoever uses that anymore, everything looks horrible, which typically is the case. So again, it has a lot of very nice facilities. Not all of them are very easy to access. You have to do a little bit of a Stack Overflowing, but they're there. Okay, so we have a very simple Rails application. And the application that I put together basically uses the device gem to add some of the authentication login pages to a bare bones Rails application with a little bit of Twitter Bootstrap in there just to make it look palatable. I'm also adding a few static pages using the high voltage gem that allows you to basically embed static pages into your app and without having to create a whole controller hierarchy to serve your own pages that are just static. So if you have Git installed, I would like you to clone the repo sitting at my company's GitHub account, and it's called learn RSpec.capybara. So you might as well just go to that URL and then copy the Git URL from there, unless you can copy and paste from the slides, which sometimes with PDF might be questionable. So I'll give you guys a couple seconds to clone that repo, and then we'll have some fun with it. Yes?
A question about using Capybara. When you're using Capybara, do you recommend just scripting all the user interactions against the page, or would you be thinking of creating objects? Is that
so there's a pattern called the page model pattern, where you really encapsulate all the tests, all the interactions with a single page in one place. For single-page applications where you have, let's say, a Rails application that's using something like Backbone, and you have 5 single-page applications living in one Rails app, that's a pretty good pattern. If you have, which this doesn't happen very often anymore, if you have a very long navigation-driven app where you're going through, let's say, 10 different URLs to get something done, which I don't think any of us do anymore, but let's say that you're building software for the IRS or something like that, and you have a 20-step wizard. It's the IRS, they'll probably do something like that just to torture you. In that case, then the page object model kind of breaks down because you really want to test across a large collection of pages to get that expected behavior of the application in that context.
I guess the question is actually a bit more simple than that. It's whether or not you would do a visit root page, or would you do a click, whatever link. I mean,
it depends. If there's some state that is going to be, so let's say that I'm using the bookmarks, the HTML5 bookmarks API. Well, if I do a navigator, if I do a click, it might be different. So in that case, yeah, I would pick one or the other based on the context that I want to have ahead of time.
Okay, so you have to think different.
Yes, yeah. All right, so I'm going to assume that everybody has the Git clone, Git repo clone. No? Slow? 40 people cloning a repository over a Wi-Fi connection? Yeah. All right. While that is happening, but everybody has it typed in there, so it's crunching. Okay, good. All right, so I'm going to show you basically what the app does first. Once you get the repo clone, I want you to cd in and out of the directory. So RVM basically recognizes that we have an .rvmrc file. I want you to do gem install bundler if you don't have bundler, and then go ahead and bundle the whole thing. And then you can launch it with Rails S. But I'm going to do that in here so you can see what I have. So this application, and just to give you a preview here, if I run the tests that I have for this application, I have 2 passing tests right now, and everything else is pending. And that's really what we're going to be fleshing out in the application. But as you can see, the browser was launched in there just for those 2 simple tests that we had in there. So let me launch the application. You can see what it does. I hope you guys copy that URL because I'm moving away from the page. So, all right. So here's our simple app. It has its style with Twitter Bootstrap because who doesn't do that nowadays? And I have a home page. It's all lorem ipsum dorum, Pig Latin, and an about page. I have a sign up. If I go to my sign up, I can sign into the simple app, and that will take me to the, if I were to, I already registered. Let me switch that to Gmail. Whoever owns a dog, please get out of the room. Okay, so let me sign into my application. And that takes me to the home page. Notice that there's a flash message using the Twitter Bootstrap alerts. And I have a profile page for the user where you can go and change your username and password. This is all courtesy of Device. So Device basically gives you all this stuff for free. And the home and about pages are just static pages that I'm serving with high voltage. Basically what high voltage does, it's create a pages controller that grabs the default URL, and if it matches one of the pages that you have stored, it will serve it. Very simple. I also have a sign out page, a sign out button to log out of the app. Okay. So, you guys clone that repo? Excellent. Okay, so like I mentioned before, you want to CD in and out of the application. You want to bundle install, regdb migrate, and then regdb test prepare. If you guys work with Rails on a daily basis, I probably don't have to tell you what that means, but we really want to, I'm using the SQLite database, so this is just creating the DB files that we're going to be playing with, because it would be cruel if I make you actually have a database, a real database installed on your systems. So if you launch the application, you should see the pages that I just showed you. And I have those on the slides too, but I'm going to move through that and get to the meat of the Capybara section. So if you were to run RSpec spec on the application directory, you would see that this is really hard to see, isn't it? Black backgrounds always get me. But see, I use white backgrounds on the rest of the slides, but black backgrounds on the actual code. I just want to be able to read what you. So we have 2 specs that are passing. And those are very simple specs at the model level. All the real Capybara specs are pending. Now, this is a little easier to read. The 2 specs that are passing are very simple specs that I'm using as pseudo matchers to basically test that my user object actually validates the presence of an email and also validates the uniqueness of an email. If you are used to testing your own validators, you typically will create an object without the email and then make sure that it's invalid and then check the errors hash to find out that there's a message there that tells you that it needs an email. So the shoot matchers basically do that for you in a one-liner, so it's pretty nice. But I really just gave you that so there would be something that actually passes. Everything else, it's a pending spec. And here's the first one that we have. It's a non-JavaScript Capybara specification. Notice that it's in the context of success. And then before this, this is about sessions, about logging in. So this is when I log in successfully. Before I want to sign in, I want to try to sign in, then I want to check that there's a welcome message being displayed. So remember we saw that flash message in there, or that welcome banner. Actually, I think it was an H1. And then I want to make sure that the correct links are present now. So if I'm not logged in, I should see the sign in and sign up. And if I'm logged in, I should see the sign out links. All of them are pending. The two specs that we have here are pending, and we have nothing to basically set the stage for the test on the before block. And you will find that under the spec directory under features. Now, your user acceptance testing goes into that features folder when you're using RSpec and Capybara in combination. Now, the first thing I want to do is try to log in. And I'm going to assume that I have a correct and valid username and password. So I'm filling in the email field with something called email, and we'll see what that is in a second. And I'm filling in the password field with a password. Then I'm clicking the sign in button. So that is setting the stage for my test. Now let me go to the code and show you what that looks like in the larger context. And I'll make this a little bigger. So up at the top, I'm creating a user. My user has an email and password. I'm using factories in here. And then I have my jill@example.com with the password. And here's the test that you were just looking at. In the context of the user sessions, when I successfully log in, I want to display a welcome message, and I want to show the correct navigation links. Okay? Now, to look for that welcome message, I'm using RSpec expect method. I'm going to expect something off the page. So Capybara makes this page object available to you. So I can interrogate that page object for certain things. The simplest thing that I can do is ask the page if it has some content. And you really don't have to navigate through the page. So this is a very precarious way to find content. Because if you were to have that message repeated in a couple places, then you wouldn't know why you're passing or failing the test. But for a simple page, this would do. You can also scope those searches. So I can say within a specific div or a specific span in my page, then look for some content. But in here, I just went to the whole page as a global object. So I'm saying expect the page to have the content sign in successfully. And just to give you an idea, let me so I obviously have a version of this that it's already fleshed out. So notice up at the top, I have my fixtures being set. Before the whole set of tests, I visit the root path of the application. And within the nav bar, within the element with the nav bar class, I click the sign in link. Then, notice that I have another block, which is the context of succeeding. I further do more actions in that before block. So all these before blocks, they will chain together. So you might have a very simple scenario that navigates to the page at the top level, one that basically tries to sign in, and then once it tries to sign in with an incorrect password. And you can keep on enhancing that set of preconditions to basically create the right scenarios in there. Sometimes it can get a little hairy, so we refactor those before and after blocks into simple methods that are easy to read. So we can say, sign in or attempt to sign in with wrong password, and then try to click on the register again with the same email. So we also make like a mini DSL to deal with our before blocks, which really helps in the long run. So now here we have the test where we expect the page to have the content sign in successfully. Now the next test, I'm looking for links. So I want to make sure that the right links are shown when the user is logged in and when he's not logged in, when he or she is not logged in. So now I'm scoping my search. I'm saying it shows the correct navigation, it shows the correct navigation links, within this navbar element. So you can use CSS selectors, and that's a very nice feature of Capybara and RSpec in here. So if you're using jQuery every day, you're probably a ninja at dealing with CSS selectors. That knowledge translates directly to writing your Capybara test. So within my navbar, I'm expecting the page, but now that page is not the whole global page. It's just scope to that navbar to have a link with the title profile. In Capybara, it's pretty smart. By default, it's trying to assume that the things that you're mentioning are the visible things so this would be the text inside of that that anchor. If you wanted to look for something specific, like let's say it has a data-attribute with some value, then you have to get a little more down into the core of the markup to specify that. But by default, if you can see it, Capybara can get to it. So I'm checking for the two links for the profile and to be able to sign out, because I'm signed in correctly. And I should not have the link to sign in or the link to sign up. All right. So let me show you those two in the context of the whole testing class. And since we're getting close to run out of time, I'm going to just run this so you can see what I like to experience every time that I'm working with Capybara. Obviously, when you have a very large suite of tests, you don't want to run them all at the same time, but I run one specific one that I'm working on, and allows me to keep on playing this movie of what I'm doing really fast in my mind, and it becomes a really dynamic approach to building your app. So I believe that's the master branch. Oh, by the way, so there's two branches on that project. The master branch has the application fully fleshed out with the tests all pending. The testing branch has all the tests passing. So if you do a git checkout testing or test, or you do a git branch and you see the list of branches you have in there, you can check out the testing branch and see it all fleshed out. So let me go ahead here and run my test. And obviously, this is the full-blown suite of tests running. So I'm checking a bunch of different stuff, and you can see from the specs what we're checking. We're checking that the flash notices show up. So those are JavaScript tests. I'll show you in a second how those work. I'm checking the page for navigation links all throughout the different activities that we're doing. And I'm checking the cancel registration feature. So now the flash notices, it's a JavaScript test because those flash notices are activated by Bootstrap using JavaScript. So for that, I have to add the .js after the name of my describe block. Notice before that block, I'm visiting a specific page. So you can use name routes in your Capybara specs. You don't have to put a string URL to navigate to something. So it's very nice. It's also an extra layer of testing of your routes. Then we have the user, the flash message should be able to be dismissible by the user. So what we're doing now, that's a pending test. To pass it, I'm first going to check that it's there. I'm going to say I expect the page to have that flash message. Then, within that alert class, which is the div that wraps the whole thing, the whole alert message, I'm going to find the close button, which has a close CSS class, and I'm going to click it, therefore dismissing the dialog. And after that, I'm going to check that the dialog went away, that the alert message went away. So that's typically the scheme of how you go about testing something like that. Again, all I had to do to enable the JavaScript behaviors was to have that .js in my describe block, and now I can say, it's a dialog there? Yes. Go inside the dialog, find the close button, click it, and check that the dialog has gone bye-bye. All right. So I think we're coming down to the closing of the session. And what I have left in there for you guys, it's if you don't want to jump and peek into that branch that has all the tests already fleshed out, you could try to do that yourself. And it's actually a very good exercise. This spec, since we use device with pretty much every application, it's tests that we carry around in a more compact form than this, but you get the idea. It's something that you probably want to have there from time to time. This is, again, it's testing device. Is that a good thing? It's not code that you own. So that's a good question. Now, what tests, though, is that if I switch from the device version to another device version, that the same things that device did for me before are doable still. And that's one thing that I like to do. And I do that with open source projects, too. So let's say that I build my application against a gem that's version 1.0, okay? And now they come up with a 2.0 version. Well, what I would do is put the 2.0 version of the gem in there and use their specs for the 1.0 to verify the behavior. So that gives me a checklist of the things that should be broken now, the places that I have to look for refactorings to perform. So hopefully this was illustrative enough to get you guys going. Again, Capybara, RSpec, it's now second nature in the Ruby community. In Capybara, the velocity of getting things done with Capybara versus using Cucumber, at least for me, it's tenfold. I feel that I can express my tests in the language that I use every day, and I'm still being able to do BDD, outside-in testing, in an efficient way, in testing only the stuff that matters. Questions? All right. Thank you very much, guys.